Welcome to the wild world of destructive testing. Chapter 31, place to remember. Alright guys, let's do this. Destructive test types, the location of specimens, specimen preparation procedures are indicated and controlled by the fabrication code or standard. That's like AWS D1.1, API 1104, ASME Section 9. These all dictate what type of tests that need to be performed in order to be qualified. Okay? A tensile test is a destructive test that measures the effects of a tensile force or a pulling force on a material. Tensile specimens usually are from welded joints, but can be rectangular unless they're taken from where it's not possible to obtain a specimen rectangular, and we're going to use what? It's going to be circular, or I should say cylindrical. Tensile specimens are usually dog bones. Okay? That means the specimen in the middle is a little bit narrower than the edges, and that way it has something to grab onto. When we qualify a welding procedure, maximum load, tensile strength, and where it fails is recorded on our procedure. Okay. Metal fatigue failure is caused by a cyclical or repeated mechanical action on a member. Soundness test. Determine if it is free of imperfections such as inclusions, porosity, incomplete fusion, and cracks. And we'll talk about that a little bit later on discontinuities. The guided bend test is the most commonly used soundness test for groove welds. Remember that. Typically, one face specimen and one root specimen is used for a standard guide bend test up to 3/8 of an inch. Okay? Now, if we're doing an inch thick, we're going to use side bends. Okay? The fillet weld break test with a macro etch is usually used for the qualifications of welders and welding operators. Usually, we're going to do a fillet weld break test like if we're doing a TIG qualification. The objective of a nick break test is to break it so we can look inside it to look for imperfections or discontinuities like porosity, inclusions, cracks, or incomplete fusion. All right, indentation hardness is applied across an area like the HAZ, and it uses that impression produced by that indenter to determine how hard it is. The Rockwell hardness test is the most commonly used and most versatile. Okay, remember that, Rockwell. Micro hardness test, micro, small, uses very light loads, less than 200 grams. The purpose of a toughness test is to compare the toughness of weld metal in the specimen with maybe the base metal to see if the mechanical properties of the base metal have not been altered. Okay, toughness test. Sharpie V-notch uses the energy produced by dynamic load and measures the energy needed to break the specimen. Sharpie V-notch have a little V in it, and they're tested at different temperatures so that we can understand how the material will react within a specific service condition. Are we using this in Arizona versus Alaska? You know, is it going to break? Is it going to become brittle? Okay. Proper specimen preparation is really important, especially when we're doing these tests, because if it's not correct, we can have problems and it can give us a false positive or a positive false, I don't know. All right, here we go. What artificial value is created for metals that do not have an exhibit or do not exhibit a yield point? Okay, and the artificial value that is created for metals with no yield point is called the modulus of elasticity. It tells us how much stress is required to deform metal a given amount while being able to return to its original size and shape after the force is removed. Okay, so modulus of elasticity. Which has a lower value in a tensile test, yield point or ultimate tensile strength? Yield point. Okay, and if you look at the load extension curve, it peaks at E. And E is the ultimate tensile strength. And if we look at F, F is where it fractures. Okay? What are the two measurements of ductility obtained in a tensile test? Well, percentage of elongation and percentage of reduction are measurements of ductility that we use when we get a tensile test. What types of welds are usually assessed in a shear test? Well, usually we're going to use it for shear strength. And a lot of times we use fillet welds, brazed welds, and even spot welds. What type of welds can we see at a peel test? Well, pretty much we can use all of them, but it's not for thick materials or high strength steels. So really, we're going to use it for thinner materials a lot of times, just spot. All right, is a bend test a qualitative or quantitative assessment? Qualitative, quality. Quantitative, quantity, how many. So it's going to be a quality. What is the quality of my weld? What is a common test used for qualifying welding procedures and welders? We know that bend tests are used to qualify welders and procedures. What types of weld orientations may be specified in a bend test? Well, really we can have orientation. Which way are they facing? Okay, so that can be root, side, or face. When they say that, the face is in tension, the root is in tension, or the side is in tension. What types of bend locations can be specified? Well, really, we're talking about root, face, or side bends. Okay. All right. Why is hardness testing commonly used to measure properties of materials? Well, they're used as a quality control. Okay. And because we can use it for heat treatments, because they're quick and pretty much non-destructive to a certain effect, which means once they do that indentation, they can grind it off and they can still use the part if it doesn't fail. Okay. What are the main types of indentation hardness tests? Burnell and Rockwell. What is the most common? Rockwell. What are the static and dynamic conditions during a toughness test? Okay. The static condition would be the force applied to a specimen. Okay. The dynamic condition would be the impact onto the test. All right, what is the most common test for welded samples? The most common test is the Sharpie V-notch. Okay. All right, here it is. This one you might have to use your brain a little bit. Maybe not, I don't know. All right, is a material with a Sharpie value of 60 foot-pounds 4 times tougher than a material that has a Sharpie value of 15 foot-pounds? Well, ultimately, we're missing information here. Okay, so not really. A material isn't stronger than others unless we have some information, okay? So some specifications require a minimum Sharpie V-notch for steel products of 15 foot-pounds at the minimum expected surface temperature. But, it doesn't mean that the test specimen at 60 foot-pounds is 4 times tougher than the minimum. We're not taking into account how hot or cold it is and how we're going to be using it, okay? So what is the name used to describe the transition of material from ductile to brittle behavior and vice versa? Well, when we're having that transition, hot to cold, cold to hot kind of thing is pretty much how they're describing it. It's called nil ductility transition or nil ductility, okay? N-I-L, ductility transition. All right, guys, please drive through.